Hi, this video is for Tuesday, March 31st. Today we're going to be learning about composite functions. So a composite function is a function that is made up of two or more singular functions and they're put together. Okay, so what it could look like. The notation could look something like this. And no, this doesn't spell fog. This right here means f composed with g. Okay, so they're both separate functions. You're going to take the g of x function and replace x in the f function with the entire g of x function. And I know that's probably a lot to take in, so I'm going to show you later. Okay, it could also look like this. And this means the g function composed with the f function. So you take f, the whole f of x function, and you replace x in the g function with the entire f of x function. Okay, so we're going to start with example 1, and it will make more sense after you see me do it. Alright, so part A here says f of x equals 2x plus 3, g of x equals 4x minus 5. We're supposed to find this. Okay, so what this means is you start with the letter that's closest to x. So we start with the g of x function, which is 4x minus 5. And we're going to take this entire function and plug it in for x in the f of x function. So we're going to start out 2 and then parentheses. We're replacing x with 4x minus 5 plus 3. Okay, so now it's just a matter of simplifying that. So we're going to distribute the 2. So 8x minus 10 plus 3. So that's going to equal 8x minus 7. And that's it. Okay. Now on part B, we're going to have something slightly different. And we're going to have these two reversed. So stay tuned for that. So this is still example 1. Part B says if f of x is 8x minus 3 and g of x is 2x plus 5, we're supposed to find g composed with f of x. So f comes second this time. It's the closest to x. So we're going to take the f of x function, which is 8x minus 3, and we're going to replace x in the g of x function with 8x minus 3. Okay, so it's going to look like this. Alright, so again we're going to use the distributive property, and we're going to get 16x minus 6 plus 5. Okay, so that simplifies to 16x minus 1. And that's it. Okay, so that's not too bad. It's going to get a little more crazy when some of our functions have squared portions, like x squared. But that just means we'll have to write that part twice and then do the FOIL method. Alright, so example 2, part A says f of x equals x squared minus 3x plus 5. And g of x equals 3x plus 2. We are supposed to find f composed with g of x. Okay, so we're going to take the g of x function, which is 3x plus 2, And we're going to replace every x in the f of x function with 3x plus 2. So that's going to take a little bit of space. So 3x plus 2 squared minus 3 times 3x plus 2 plus 5. Okay, now anytime you see a quantity squared, that means you write this twice and you FOIL it. So you write this twice and you FOIL it. Okay, so if we write that twice and FOIL it, what we get is 9x squared plus 6x plus 6x plus 4. So I'm going to condense that a bit. It'd be 9x squared plus 12x plus 4. In this part here, we're going to distribute this negative 3. So minus 9x minus 6 plus 5. Okay, so that's a lot of algebra that just happened. Now we have to combine our like terms. So one more step. 9x squared. Now let's see, we have 12x minus 9x. So that's going to make 3x. And then we have 4 minus 6, which is negative 2. And negative 2 plus 5 is 3. So we're going to have 9x squared plus 3x plus 3. Like that. Okay, so I told you, it gets a little more work. There is more work. I think we've been in quarantine too many days. Words are... Anyway, there's a little more work when you have a quantity squared because you have to write it twice and then FOIL it. Okay, so now we're on to part B. Alright, part B says f of x is x squared plus 2, x, and g of x is 5x minus 1, and we're supposed to find g composes f of x. Okay, so we're going to take the f of x function, x squared plus 2x, and plug it in for x in the g of x function. So it's going to look something like this. Okay, so that's going to be 5x squared plus 10x minus 1. Okay, none of those are like terms, so that means we're finished. That's it. Okay. Alright, now, example 3. It's not going to just be left like this anymore. I'm going to give you a number to plug in for x. Now, don't be alarmed. It won't be that hard or that bad. So, here we go. Alright, example 3 says f of x equals 4x plus 5 and g of x equals x squared. We are supposed to find f composed with g of 3. Okay, now when this happens, you can take 3 and plug it into the g function first. That's what I would do. So take 3 and plug it into the g function first. So if we take 3 and put it right here, what is 3 squared? 9. Okay? So, g of 3 is 9. Now we're going to take our 9 and plug it into the f function. So we took 3, plugged it into g. We're going to take our answer from that, 9, and plug it into f. So now, 4 times 9 plus 5. So 36 plus 5, 41. Okay, so you take the number, plug it into the closest letter function first, get that answer, and then you plug it into the other one. So hopefully that made sense. If not, you can send me messages and I'll get back to you. Okay, so that was Composite Functions Day 1. You will have a Google form to fill out on these things, and the notes and this video will be posted to Classroom, so I hope that that helps. And I wish that I could see you in person to teach you, because I miss you lots. So take care. Bye.